In March of 1968, a Soviet submarine carrying nuclear weapons simply disappeared beneath the Pacific Ocean. For 6 years, the Russians searched desperately while the Americans knew exactly where it was. The K-129 had become the most valuable wreck on the ocean floor. And what the CIA found when they secretly raised it would change everything we thought we knew about that Cold War voyage. But here's what makes this story different from every other submarine mystery you've heard. The Americans didn't just find the K-129. They stole it, piece by piece in broad daylight, while the entire world watched and had no idea what they were seeing. And when they finally got inside that rusted hull, what they discovered would reveal the true cost of Cold War submarine warfare and the lengths both superpowers would go to hide their deadliest secrets. The K-129 wasn't just any submarine when it left port in February 1968. It was a floating nuclear arsenal departing during the most dangerous submarine patrol of the Cold War. This Gulf II class ballistic missile submarine carried 3 R-21 missiles, each armed with 1 megaton nuclear warheads capable of striking targets 750 nautical miles away. The submarine's torpedo room contained its standard defensive armament, 2 T-5 nuclear torpedoes, weapons specifically designed to destroy American carrier groups that might threaten Soviet ballistic missile submarines on patrol. These weren't experimental or unauthorized weapons. They were exactly what Soviet doctrine called for during the height of nuclear tensions. The paperwork told one story, but the reality was more complex than anyone understood. When Captain First Rank Vladimir Kobzar ordered his crew to prepare for departure from Rybachi Naval Base near Petropavlovsk-Kamchatsky on February 24, 1968, he was commanding 98 men, 15 more than the Gulf II's standard complement of 83. Naval records list them as specialists and technicians, but their specific roles remained classified even in Soviet archives opened after the Cold War. The timing of the K-129's departure wasn't coincidental. Just weeks earlier, on January 23rd, North Korea had seized the USS Pueblo in international waters, capturing 83 American sailors and triggering the largest naval mobilization since the Korean War. Soviet Pacific Fleet commanders were positioning their most dangerous submarines throughout the Western Pacific, creating a nuclear deterrent screen that could strike American forces if the Pueblo incident escalated into full-scale conflict. The K-129's official orders directed it to patrol a predetermined area in the North Pacific, where Soviet ballistic missile submarines traditionally conducted their deterrent missions. But something about this patrol felt different to the sailors who watched the submarine disappear into the gray waters of the Kamchatka Peninsula. The extra crew members meant cramped quarters and reduced patrol endurance, sacrifices no captain would accept unless those specialists were essential to the mission. Soviet naval doctrine during this period was clear. Ballistic missile submarines carried nuclear weapons for one purpose: to ensure that any American first strike would be met with devastating retaliation. The K-129 represented the cutting edge of this doctrine, a diesel-electric submarine capable of hiding beneath the Pacific's thermal layers while its nuclear missiles stood ready to incinerate American cities. What made this particular patrol different wasn't the weapons or the crew. It was the timing. The world was closer to nuclear war in early 1968 than most people realized, and submarines like the K-129 were the thin line between deterrence and catastrophe. On March 8, 1968, American listening stations across the Pacific detected a sound that would haunt naval intelligence for decades. The U.S. Navy's secret SOSUS hydrophone network had been tracking the K-129 since it departed Russian territorial waters nearly 2 weeks earlier. Underwater microphones stretching from Alaska to Hawaii detected the submarine's distinctive acoustic signature: the rhythmic thrum of diesel engines, the whisper of water flowing over the hull, the mechanical heartbeat of a vessel designed to disappear beneath the waves. The K-129's last confirmed radio transmission had occurred on February 26th, a routine burst communication that told Pacific Fleet headquarters the submarine was proceeding as ordered. But on March 8th, the hydrophones picked up something that no submariner ever wants to hear: First came a series of sharp cracks, like metal fracturing under impossible pressure. Then a deep, resonant implosion that registered on acoustic sensors across the Pacific Rim. Two explosions occurred 4.8 seconds apart, captured by SOSUS stations, and triangulated to coordinates approximately 40 degrees, 6 minutes north latitude, and 179 degrees, 57 minutes east longitude, 1,560 nautical miles northwest of Hawaii. In international waters deeper than Mount McKinley is tall. The acoustic signature was unmistakable. A submarine's pressure hull had catastrophically failed at crushing depth. Soviet Pacific Fleet headquarters didn't immediately realize what had happened. When the K-129 failed to make its scheduled check-in around March 11th, fleet commanders began broadcasting emergency recall orders on frequencies that should have reached the submarine anywhere in the North Pacific. For weeks, Soviet search aircraft flew grid patterns over vast stretches of ocean, concentrating their efforts 300 miles east of where the submarine actually lay, a navigation error that would prove fortunate for American intelligence. Within months, the USS Halibut, a specially modified nuclear submarine equipped with deep-sea cameras, received classified orders to investigate the acoustic event. What her crew discovered when they reached the coordinates would reshape Cold War naval intelligence. The K-129 had broken apart during its descent, with debris scattered across several hundred yards of abyssal plain at 16,000 feet below the surface. The damage told a story of internal catastrophe. Photography revealed a 10-foot hole aft of the conning tower, blast patterns consistent with explosion from within the pressure hull, and structural damage that suggested the submarine had suffered what naval architects call dieseling, the catastrophic compression that occurs when submarine compartments fail, creating temperatures hot enough to ignite fuel vapor and turn metal into projectiles. But the timeline raised questions that Soviet investigators would never get the chance to answer. If the K-129 had stopped communicating on February 26th, what had happened during those 10 days before its final destruction? Had the crew been fighting to save their submarine while their own navy searched for them in the wrong ocean? 6 years after the sinking, the CIA launched the most audacious theft in maritime history, publicly disguised as a deep-sea mining project, but secretly designed to steal a Soviet submarine from the ocean floor. Project Azorian began as an intelligence fantasy and evolved into an $800 million engineering marvel that pushed 1970s technology to its absolute limits. The operation required the construction of the Hughes Glomar Explorer, a 618-foot vessel that appeared to be a commercial mining ship, but contained technology that wouldn't be declassified for decades. The ship's cover story was perfect. Howard Hughes, the eccentric billionaire, was funding experimental deep-sea mining technology to harvest manganese nodules from the ocean floor. It was boring enough that journalists wouldn't ask difficult questions, and profitable enough that the operation could sustain congressional oversight without arousing suspicion. But hidden within the Glomar Explorer's hull was a mechanical marvel, a massive claw system capable of lifting thousands of tons from depths that would crush conventional submarines like aluminum cans. The ship's crew included CIA operatives posing as mining engineers, Navy deep-sea specialists operating under commercial cover, and legitimate oceanographers who believed they were conducting cutting-edge geological research. The salvage operation began in July 1974, with the Glomar Explorer positioning itself directly over the K-129's grave. For weeks, the crew worked in shifts around the clock, slowly lowering their mechanical claw toward a target they could barely see through cameras operating at the edge of technological possibility. What they found contradicted some assumptions, but confirmed the essential tragedy of the K-129's loss. The forward section contained the submarine's 2 nuclear torpedoes, still intact after 6 years on the ocean floor. Radiation detectors registered contamination from damaged warhead components, but there had been no nuclear detonation. The weapons had simply been breached by seawater and the crushing pressure of the deep ocean. The torpedo room revealed evidence of the catastrophic explosion that had killed the submarine. Twisted metal, melted electronics, and blast patterns painted a picture of mechanical failure escalating into total destruction. cryptographic equipment, standard for Soviet ballistic missile submarines conducting secure communications during patrol, remained partially intact, offering American intelligence analysts insights into Soviet naval procedures. The Americans documented everything, creating a detailed record of Soviet submarine technology that would influence U.S. naval development for the next decade. Deep-sea cameras captured images of the crew quarters, where personal effects floated in the eternal twilight of the deep ocean. Photographs, letters, personal items that told the human story behind the strategic significance. The salvage operation successfully lifted a 38-foot section of the K-129's bow, but mechanical failure struck at the worst possible moment. The claw system's grip failed as the submarine's hull was being raised, and most of the wreckage, including the missile compartment with its 3 nuclear warheads, fell back into the abyss. The Americans had managed to recover crucial intelligence materials and the remains of 6 Soviet sailors, but the submarine's most sensitive secrets disappeared into crushing darkness. Among the recovered materials were the bodies of 6 crew members, preserved by the cold and pressure of the deep ocean. CIA documentation shows that American intelligence officers identified the sailors using Soviet naval records and arranged for them to be buried at sea with full military honors. Their ceremony conducted in Russian by operatives who had studied their enemy's culture with academic precision. In 1993, CIA Director Robert Gates handed Russian officials a brass bell and a videotape that would finally provide closure for families who had waited 25 years for answers about their loved ones. The tape showed 6 Soviet sailors being buried at sea with honor guard precision, their bodies wrapped in Soviet naval flags, while American intelligence officers read burial prayers in fluent Russian. The ceremony had taken place aboard the Glomar Explorer in 1974, with the same men who had spent months stealing enemy secrets, taking time to honor the sailors who had died serving their country. The gesture represented something unprecedented in intelligence history. American operatives had not only identified the dead using classified Soviet naval records, but had researched their service histories, learned their religious backgrounds, and conducted burial ceremonies according to Russian Orthodox tradition for families in Kamchatka and Vladivostok. The video provided answers that their own government had never offered. The official Soviet response to the K-129's disappearance had been bureaucratic silence. Families received death certificates listing their relatives as missing, or in some cases, deserter, classifications that invalidated survivor benefits and created legal complications that persisted for decades. Wives and children spent years fighting Soviet bureaucracy for basic acknowledgement that their husbands and fathers had died in service to the state. But Project Azorian's legacy extends far beyond Cold War intelligence gathering. The operation demonstrated the extraordinary capabilities that intelligence agencies could deploy when national security demanded technological innovation. The deep-sea recovery systems developed for the K-129 salvage influenced commercial underwater operations, offshore drilling technology, and marine archaeology for decades. The human cost of the K-129's loss represents more than the 98 men who died in March 1968. Submarine warfare during the Cold War extracted a hidden toll that both superpowers preferred not to acknowledge. Intelligence estimates suggest dozens of submarines from both sides were lost to accidents, mechanical failures, and undisclosed incidents during the 1960s and 1970s, with thousands of submariners simply vanishing beneath the waves without public explanation. The environmental questions raised by the K-129 incident continue to influence naval policy today. While the specific wreck site doesn't show evidence of ongoing radiation leakage, the broader issue of nuclear submarines on ocean floors represents an emerging challenge as Cold War-era vessels reach the end of their structural integrity. The K-129 contained nuclear warheads and radioactive materials that will remain hazardous for thousands of years, raising questions about international responsibility for cleaning up the ocean floor legacy of nuclear deterrence. For the families of the 92 crew members whose bodies were never recovered, the K-129's story remains unfinished. Their relatives lie in a steel tomb 16,000 feet beneath the Pacific, honored by enemies who knew more about their final moments than their own countrymen. It's a legacy that speaks to the hidden human costs of the Cold War and the strange honor that can exist between adversaries who understand the price of serving their nations in the deep ocean. The K-129 incident reveals how the Cold War's most dangerous moments often played out in complete secrecy, with submarines carrying nuclear weapons operating at the edge of mechanical and human endurance. The submarine's crew died not in a dramatic naval battle, but in the mechanical failure that was every submariner's nightmare, trapped in a metal tube as it plunged toward the ocean floor, with no way to signal for help and no hope of rescue. What makes the K-129 story particularly sobering is how close the Cold War came to nuclear catastrophe through simple mechanical failure rather than political miscalculation. The submarine's mission was routine deterrent patrol, designed to demonstrate Soviet nuclear capability without provoking confrontation. Yet the presence of nuclear weapons in a submarine that would ultimately suffer catastrophic mechanical failure illustrates the hair-trigger nature of Cold War nuclear strategy. The extra 15 crew members aboard the K-129 remain a subject of historical curiosity rather than sinister mystery. Soviet naval practices during crisis periods often involved augmenting submarine crews with communications specialists, weapons technicians, and intelligence personnel who could handle the increased operational tempo of heightened alert status. The Pueblo crisis had prompted similar crew augmentations across the Soviet Pacific Fleet. The submarine's final radio contact on February 26th suggests that whatever mechanical problems ultimately destroyed the K-129 may have developed gradually over nearly 2 weeks. Modern submarine accident analysis indicates that many catastrophic failures begin with minor mechanical issues that cascade through interconnected systems until they overwhelm the crew's ability to respond. The K-129's crew may have spent days fighting to save their submarine before the final explosion that American hydrophones detected on March 8th. Soviet search efforts concentrated in the wrong area, partly due to navigation uncertainties common in 1960s submarine operations. Without GPS or modern satellite communications, submarines relied on celestial navigation and dead reckoning, both subject to cumulative errors over long patrols. The K-129's actual position at the time of sinking was likely different from its last reported location, contributing to the unsuccessful search efforts. The nuclear torpedoes found aboard the K-129 represented standard Soviet naval doctrine rather than evidence of unusual mission parameters. T-5 nuclear torpedoes were specifically designed to destroy American aircraft carriers and cruiser formations that posed threats to Soviet ballistic missile submarines. Their presence aboard the K-129 reflected the reality of Cold War naval strategy, where nuclear weapons were integrated into defensive as well as offensive systems. The technology behind the theft project. Azorian's engineering challenges required solutions that pushed 1970s technology decades beyond existing capabilities. The Hughes Glomar Explorer's claw system had to operate at pressures exceeding 7,000 pounds per square inch in total darkness, guided by primitive cameras and sonar systems that provided only fragmentary images of the target. The operation's cover story required creating an entire fictional industry around deep-sea mining. The CIA established mining research programs, environmental impact studies, and corporate structures sophisticated enough to withstand scrutiny from Congress, Allied intelligence services, and investigative journalists. The deception was so comprehensive that legitimate oceanographers published peer-reviewed research based on data collected during the K-129 recovery mission. Howard Hughes provided ideal cover for the operation, partly because his eccentric reputation made extraordinary expenditures on speculative technology seem credible. The billionaire's history of funding advanced aviation and engineering projects gave Project Azorian a public face that could explain the massive costs and technological innovation without triggering deeper investigation. The mechanical failure that caused the K-129 wreckage to fall back to the ocean floor represented a devastating intelligence setback. The missile compartment contained the submarine's most sensitive technology: ballistic missile guidance systems, nuclear warhead components, and communications equipment that could have provided insights into Soviet strategic capabilities for years to come. What the recovery revealed analysis of the recovered K-129 components provided American intelligence with detailed understanding of Soviet submarine construction, metallurgy, and nuclear weapon design that influenced U.S. naval development through the 1980s. Soviet welding techniques, electrical systems, and hull construction methods revealed both strengths and vulnerabilities in Warsaw Pact naval technology. The condition of the recovered nuclear torpedoes demonstrated the robust engineering of Soviet nuclear weapons, which had survived catastrophic explosion, 6 years of seawater exposure, and crushing deep ocean pressure, while remaining structurally intact. This durability indicated that Soviet nuclear weapons could potentially survive scenarios that American designers had assumed would render them inoperative. Personal effects recovered from the crew quarters provided intelligence analysts with insights into Soviet submarine culture, morale, and living conditions that complemented technical intelligence gathered from the submarine's hardware. Letters, photographs, and personal items painted a picture of submarine life that helped American naval intelligence understand the human factors affecting Soviet submarine operations. The cryptographic equipment recovered from the K-129 gave American codebreakers access to Soviet naval communication procedures and encryption methods that had been purely theoretical until physical hardware became available for analysis. This intelligence advantage influenced U.S. naval communication security and helped predict Soviet naval movements throughout the remainder of the Cold War. The K-129 lies broken on the Pacific floor, a monument to the hidden casualties of Cold War deterrence. But what other submarines from both sides still rest in the deep ocean, their secrets intact and their stories untold? That's another story.